last video I have ended with an example of a numerical which is not a perfect square. Now if I take that example and try to explain some more facts that can be asked for in regard extending this part of perfect square and all that. So taking that number, if it is not a perfect square, what are the condition, what are the mathematical calculation by which that number can be bring to a perfect square, that may arise or may be asked in your question. So I will say one by one. So if I take the same example of that number which says this 17642. Now if you understood that this is not perfect square, as because this cannot be made into a indices of even. Okay, because this is the remaining 10. This 10 is not with the even integer, even indices. So if I being asked what is the number, first is what is the number, what is the, let's say I am denoting with n, what is the number which will be multiplied with n to get it a perfect square by dividing what would be the, it will be a, now this function could be a division multiplication to bring it a perfect square. What could be added to make it a perfect square, what would be deducted to make it a perfect square. Now to understand that one by one, I have to bring some concept, or I have to calculate something so that I can understand where this number lies. So to do that, I will follow the divisional method of doing square root of some number, because factorization will not able to bring to a decision where I can decide this number lies between two such number which is a perfect square. So to establish that, I will try to make it a perfect square. So you know the rule of division. So I will start with that straight way. 1. Now I will bring 76 down. 2, which will be divided 3 times, will give you 69, and that 7, 40, 133, 26 will come. If I go for 3, let's say, so how much it gives? 9, 6 into 3, 18, 1, 7. So this is crossing by some number. That means the next perfect square which is crossing this is 133 square, which will be higher than this. So definitely the prior one will be less. So if I try it with the 2, so it will give you 4, 6 to the 12, 2 to the 4, 5. So this definitely reduce means lagging by some number which is a which will cause it to be non-perfect. So this number, what I am to conclude that this number is lies between 132 square, between 132 square and 133 square. So this range creation is must needed to conclude all such problem related to this number, which will make it, which will convert it to perfect square. So now first thing that has been asked, what is the number multiplication factor that could cause it to be a perfect square. Okay, so now if I take it as a not a perfect square, and if I want to get the perfect square, from there I know unless and until I multiply it with another 10, I won't get number which is a perfect square. That means the number 10 must be multiplied with this number, because this is remaining in this form. So to make it is the even indices, the minimum number that has to be multiplied is 10. So in case of multiplication, this number has to be multiplied with 10 to make it is a perfect square. Or if I remove this number by dividing with the 10, then only I can make it is a perfect square. So multiplication and division can be established from the prime factorization. So if I multiply with 10, I will make it indices of 2 and it will be a perfect square. And if I divide with the 10 to remove it, remove this 10, then also that power of 10 will be 0. So this will not affect anything. So only thing is the perfect square is this one, and it will make a perfect square. So first two part where it has to be multiplied or divide with something is over. Now comes the next part, how much to be added. So adding means you have to bring the number to higher number. So that means if I add something to this to make it is a perfect square, the next possible number is 133. So better make 133 to a number of this form, or expand 133, you can say 3 3 is 9, 3 9 9 3 1 1 3 9 18 15 16 15 16 7 1. So this is the next perfect square number after this. So how much I have to add? 640 be 94000. That means 49. So your answer would be 49. 49 to be added this 2 to get it the next positive. I should not say next, because it automatically, if you add something, you will get the next higher number. And what would be the number that to be deducted to form a perfect square? Your answer should be 132 square. If you expand it, I will get 4 6 2 6 9 3 and then 2 3 1. So if I add this 2 13 14 6 7 1, so the number, the required answer should be, if I deduct the lesser number from this, and I will definitely get 6 1 2 216. So the number 216 to be deducted from this to get a perfect number. So in one shot I have explained all the such condition, the procedure by which you have to approach to get all this answer to be that question to be answered. Okay, what will be the multiplication factor, what is the divisional factor, what is the sum to be added, what is the number to be summed or added to that number, what is the number to be deducted from that number to make it all perfect number. Okay. So the next come the concept, if I square an even number will get even always. Say for example, if I square 2 square, I will get 4. If I squared 4 square, I will get 16. So the result of square is always an even number. Let's say 8 square 64. Let's say 24 square. How much it will be? 576. Is it so? 96. 4 to the 48. 48 9 576. Yes. So this way you can get all square which is even will a even number. Let's try with the odd. What I will get? 3 square 9. So this is in odd number, squaring up, getting odd number. let's say 17 square, it is a odd number. What I will get? Let's try it. 9, 7, 4, 11, 7, 1, 9, 8, 2, 289. Okay, so this is again an odd number. Let's try with 15 square, 225, odd number. 19 square, 381, odd number. So I can conclude the square of even number, if it is even, the square of odd number is odd. I can conclude this. Okay, this is one kind of property of square. So this is for now. In next class I will bring more such property of square and square root. Thank you.